Okay. Um, okay.
So I thank my team, and I'd like to request, and today my whole team is with me, all the people who are working on Arduino India. We're going to bring cool open source projects for you, webinars, tutorials, workshops for adults and children and students and non-students and lazy and clever and dumb alike. So I'd like to call my team up on the stage. And I'd like to announce officially in this platform, was waiting for electronics for you, like Electronics Rocks Conference 2013 to make this announcement. Our Arduino India office has opened in Frasertown, and yeah, it is the first office outside of Europe. And why is it so special to me? Because we'll be coming out with India-made boards. So the boards that you see with the Italy map at the back is now going to have India map at the back. It's going to be multi-purpose for industry, as well as our main focus is on education to poorer countries, maybe even poorer countries than us, Pakistan, and I'm looking for Sri Lanka, and I'm looking for Nepal, and not China boards, because as all of you know that Chinese work in jail-like circumstances. Most of the factories, the toy factories that they have over there, like people literally live in like 8x8 rooms, cramped, and all the day they are working for a very meager salary. We don't want that kind of cheap products. So that's why the factory is being set up in India. And yeah, and secondly, what we are doing, a lot of people are asking what Arduino India office is doing and what it's going to do. We're going to bring out really, really cool products and have a really good support for the community out here. We are also getting into a field called rapid prototyping for public space advertisements. And also I'd like to announce our good hand partnership with Tektronix. We are bringing us in schools, because most schools have Tektronix, in the field of test and measurement and debugging circuits using Arduino. We are announcing that too. And all in all, do write to us, do visit our stall, and let's all show to the world that we Indians are the kings of Jugaad. Like, okay. So fine, and this is my team. Just 1 minute, ma'am. This is Ankit. Ankit is joining us today from Mumbai. I'd like just 2 words from Ankit.
Hello everybody, and I hope that we can make it awesome for all of you from Arduino India.
Yeah, thank you, Ankit. And this is Nidha, and Nidha is also an engineer.
Hi everyone, I'm the junior design engineer. I think the junior most here. So yeah, I have nothing much to say. I think Priya said most of it.
And Avik, our man of the day, having a bad day, but any case, please give him a big hand. He's worked really hard.
Alright, so well, I don't think words can justify this. I really request all of you to come join me on the stall, and we'll have a demo over there. Thank you.
All right, and for those people connected to the things, please follow us on Facebook page. We'll be posting about our plant. This plant will be our official Arduino pet. Feel free if you feel you're having a bad day, if you want some good karma of watering a plant, you can just tweet to it. And details would soon be on our page. Thank you.
Thank you, Priya. Thank you, the team. And we'll surely look forward for the demo at their booth. Okay, we now move on to our next session, and for the same, we would like to introduce Mr. Janardan Revuru. Janardan has 17 years of technology background working with Siemens, Motorola, and Nortel. He worked on products in wireless and data networking space. He is currently working for HP. He has authored more than 20 articles in various magazines, and he's also been a speaker at technical and management conferences. So now over to Mr. Janardan. Thank you.
Attended yesterday's session on Bluetooth Smart and accessories. Anyone? Okay. So yeah, there was a session yesterday by Nitin Gupta. He had covered pretty much on the accessories part and the application side of Bluetooth Smart. Since there is a good amount of overlap, I wanted to cover a different perspective of Bluetooth, more from an engineering side. And initially the topic that I had chosen was Bluetooth 4.0 and Internet of Things, but the amount of coverage I have seen in the last 2 days is I hope it's quite enough for you to understand the Internet of Things. So I'll mostly focus on Bluetooth 4.0 and how does it enable the opportunities for Internet of Things. So as I mentioned, this is more about the how and why part of it rather than covering about what are the beautiful things you can do with Bluetooth. So I'll be more giving you an engineering perspective. Okay, the audience I'm going to cover, whom I am hoping to will be interested, will be engineering view of Bluetooth 4.0, the design decisions they have taken when they have to come up with a low cost and low power, low energy utilization protocols. And it also helps app developers. If you are an app developer for any mobile applications, if you want to really exploit the capabilities of low energy, this is the forum where you can understand why certain decisions have been taken, whether you should go for a 4.0 option or should you go for devices which are more Bluetooth classic. And the next one is enthusiasts and technologists. Like, there will be people where age no bar, but I have seen people attending these sessions where, irrespective of the domain they come from, they are still interested in any technology that they work on or don't work on. So this is even covering those people. And now a quick recap of people who did not attend the session yesterday, just about what Bluetooth low energy enables. If you see the initial purpose of Bluetooth Classic, what we call the version 1, version 2, version 3, the main protocols were supporting, or the idea was to support replace a cable, okay, for any data transfer or any communication. That was the real purpose of wires which were connecting from mobile phone to the headsets, or the wires are connecting for file transfer. And if you see Bluetooth LE, the fact sheet that was presented yesterday, the focus was with the low data rates, what are the kind of applications that we can address, okay, and what is the power consumption of that. It is few milliseconds that it goes to, right? So how is it able to, those are the details that we had seen yesterday. And market adoption, this is one place where I feel Bluetooth special interest group, if at all they are successful, they are very successful in marketing the product such a way that that the top 3 big shots like Google, Microsoft and Apple are deploying the Bluetooth low energy at a much faster rate. And even if you see the announcement happen in terms of Google Android APIs, they are available from 4.0 so that people can start using the low energy features. And yesterday Nitin had covered about the LE applications, which are some are very smart, some are not so smart, but various types of applications that are possible. One is sports and fitness, where example like Nike Plus, the fuel band, where it will start checking how many steps you have taken, and then it is integrated with your iPhone. And some applications like home automation, if you want to switch on a light or or check the status of it, those are some of the applications that are targeted in Bluetooth low energy. And wearable computing, remote controls and smart meters. So these are the various applications. Mostly if you see, these are applications which are supposed to be not like a streaming content, but it is more suppose the data exchange that is going to happen, which is very, very less frequent. That is the real intention for most of the applications. Yeah, if you see remote controls, they were mainly focused in terms of the infrared, where the line of sight was there, and there are other applications that are coming, which are the wireless technologies that are coming, which are going to, and Bluetooth is one of the technologies that is going to enter the living rooms, where the remote control of in front of the TV is going to also be connected to multiple other devices. So this is the space where a lot of other wireless technologies are also competing, and Bluetooth low energy is one of them. Okay. Now let's talk about Bluetooth 4.0. Bluetooth 4.0 is also as part of the specification for Bluetooth 4.0. The major mention of it, or the major highlight, is really the Bluetooth low energy. Bluetooth low energy is a new wireless specification for ultra low power devices to communicate in a personal area network. So to highlight the key aspects in the definition of it, main thing is it's a wireless specification, particularly for the low power. So if you see some of the already existing wireless technologies, Zigbee, this is also playing almost in the same space, but for a personal area network, which means that we are talking about a space which is few meters. 10 to 100 meters, not more than that. Okay, and this is one of the space where it is. And communication is the key element. If you see most of the Internet of Things, okay, Internet of Things, whether you have internet connectivity or not, the main aspect is the things are able to communicate. For them to communicate, you need to have a efficient protocol where the communication itself is not an overhead. So that is where Bluetooth Low Energy is really playing. In terms of the energy efficiency, if you minimize that, the small devices which are supposed to do some task, whether it is a clock, whether it is a temperature measurement instrument, while they do the major function, the primary function, they also are able to communicate with the least power consumption. So that is a key highlight what Bluetooth tries to optimize. And Bluetooth Low Energy is a subset of the specification, but we should not be correlating it directly to say that 4.0 is equal to Bluetooth Low Energy. Okay, here I just wanted to give the end of the presentation. The objective I am trying to achieve is, if you are a developer or a technical person, at the end of the presentation you should be able to comfortably go through the specification and get a good understanding of what the protocol is talking about. If you see majorly the Bluetooth controller, the bottom portion of it as well as the above part of it, the distinction is that we have some controllers which are some examples of the USB based Bluetooth devices which have the basic functionality of Bluetooth radio. They are nothing but the receive transceivers, they are the RF transceivers, and we have the link control where they talk about whether there are two types of links that are available in Bluetooth. One is the synchronous connection oriented link, other is the asynchronous connectionless link. So the baseband link controller gives you two options. Why do you go for one rather than the other? Mostly the synchronous communication is aimed at voice and real-time protocols, whereas the data-oriented protocols choose the asynchronous connectionless link. And above that you have the link management protocol, which is implemented as part of the small device, which does mostly the power control. It takes care of the security and also the type of device it is supposed to be playing a role. And if you go to the above, which is called the host in Bluetooth jargon, the host is typically, if you take an example of a computer, it could be your computer with an operating system. The operating system has this stack, or whenever you say an operating system having that stack, you're talking about the host control interface and the protocols above that. So this is, I just wanted to highlight here what is a host and what is a controller. The Bluetooth Low Energy tries to maximize the utilization of something more on the host and give less power consumption related activities to the controller. So that is how they have distinguished. Now, yesterday in the forum there was a question on Bluetooth 4.0. There is a common understanding that whenever a new version comes, it is assumed that it is better than the old version, or it is assumed that the capabilities are backward compatibility. Whereas in Bluetooth 4.0, one thing you can clearly remember is it is not a backward compatible protocol by itself. So which means that it is not like 2G, 3G, 4G like the mobile networks or internet connectivity, where the speed wise it keeps increasing. From 2G to 3G you can expect 10 times or more bandwidth, and from 3G to 4G you go next level and you get much better bandwidth. So that is a little bit of misleading stuff. So the 4.0, if you see, is the stack on the rightmost side, the green colored one. The Bluetooth Low Energy Single Mode is what is the 4.0 specification talking about. Whereas the Bluetooth Classic is on your left side. The leftmost side you are talking about the basic rate as well as the enhanced data rates. So the stack of both of them right from the radio frequency level is different. So only devices that are dual mode, which are in the center what is shown, will work. So which means that whenever you are getting a Bluetooth 4.0 device, it is essential you understand that it is a dual mode device if you are using for applications like streaming. For example, if you are getting a headset which is only 4.0 compliant and then it doesn't have the basic streaming functionality, then you should be watching out. So more probably the devices what are being sold in the market, mostly they will be dual mode devices. Things like mobile phones, they will be coming under the dual mode category. Only the single mode devices exclusively will be mostly devices which are really power hungry. The ones which you are talking about button cell, those are the ones which will really be operating in a single mode. This is just to highlight that if you see the complexity from a left side, the classic point of view, the number of protocols that were able to be supported were quite many. If you see the RF COM and the serial port profile, and there are many other profiles that are being supported or the protocols. Whereas if you see on a single mode point of view, they have simplified the whole protocol stack. It is only one protocol, which is the attribute protocol at the end of the day. And you can achieve a very diverse as well as rich functionality using just the attribute protocol and the one above that, the generic attribute profile. We will talk about that little more. And I just wanted to highlight here that when you buy a Bluetooth 4.0, what is the caution you have to do, and even if you are building a stack or application development you are doing, you should be taking care of this as part of the device requirements. Now we will talk about the key aspect of the talk, which is design considerations for optimization. So what are the various things that Bluetooth SIG, the special interest group has taken care for coming up with this. This is exactly goes back like, if you remember the Tata Nano, once Mr. Ratan Tata made an announcement that he is going to release a car in 3 years time, which is going to be a 1 lakh cost. The 1 lakh was the one with which the whole project was working backwards. So this is exactly the same kind of project what they have taken from a Bluetooth optimization point of view. They were not trying to achieve optimizing the existing Bluetooth Classic, rather they came up with a clean slate and they started saying that for an ideal condition for a button battery which is widely available, for that to be operating for 1 to 2 years, what are the things I should take care? So that was the main point from which they started working backwards. So all optimizations, all design choices or the decisions that were done were mainly oriented towards that. So the button cell has its own positives and negatives. One is the most positive part is the cost. The second part is the availability of it. In addition to that, there is also another aspect that the performance or the power utilization that you can do based on the temperature increase or decrease, the actual power what you can draw from that varies. So they have also taken care of the worst condition, and then in worst condition, how do you manage that? How do you optimize is one of the consideration. Next is communication consumes energy. If you see most of the devices, I think it is not new that Bluetooth Low Energy is the first application or the devices that are coming which are using button cell. There are many more already existing devices which use that. But the key part is communication consumes energy. The lot of energy that goes out, even if you see your just mobile phone, right? If you keep it in a mode where you're in aeroplane mode where you're not using the consumption, you will see that your mobile can come up to 5 days instead of just 1 day. So the consumption, because of the radio frequencies, the way we are operating, it makes a big difference. So they try to optimize the power from various points, and not only when it is operating. So they try to consider how often, how frequently is the communication required. They started optimizing on that. Second thing they started optimizing is even when I am talking or when I am communicating, can I keep it crisp? Okay, instead of just like old way of writing a big email, now if you see it's more a Twitter kind of thing where you can just have 160 characters still communicate a message. So they try to optimize on not only how frequently should I communicate, how frequently should I manage my link status, it is also about when I communicate how crisp and clear I can keep it. So that also includes not compromising on the security aspects. So they had considered all this as part of the design of it. Now memory. Memory is expensive in terms of not only the first time when you buy. So as part of the device cost, when you are talking about a device which should be the bill of materials, max could be right now $2.5. If you start adding memory for the sake of session management or maintaining multiple protocols, it consumes a lot of memory. And memory, not only the initial cost of the device goes high, but it also means that the consumption of power for memory to be, it has to be refreshed multiple times. So how do we work on that? So some of the considerations, they try to keep the memory for any session or for data to be stored on the device which is a class, which is a low energy device, that they wanted to keep it very low. So that is one of the considerations for design. Then the second aspect, as I mentioned, the asymmetric design, right? Asymmetric design is, they try to say that whichever is on the hearing side, the thing which is of low energy consumption, they try to keep the communication or any overheads least on the thing side and more on the computer or the host side. So that is one of the asymmetric designs they have considered. Right from the communication, that is where, as I mentioned, right, they started revisiting the whole protocols what they had in Bluetooth Classic for this purpose. Now, dependency on smart gateways. So how does it affect the decision? So if you see Internet of Things, Bluetooth Low Energy is really not enabling you to make each and every device to communicate with the internet. So that is a design choice, or what the design decision they have taken. Every device, if you see, which could be a light in your house, or it could be a key or a lock in your house, all these are not going to directly talk to internet. If you want to make your things to be connected to internet, the bare minimal you need is they should have the IP stack, okay, for you to communicate with internet. So in these things, or the small chips or small devices we are talking, we cannot afford to have the IP stack because of reasons like memory, which again goes up with the cost goes up because of that, and also because of the communication that he needs to maintain. For example, a TCP communication, a connection oriented, if you have to, there are some overheads in terms of sessions you maintain, as well as the amount of packets or the windowing mechanism what it has. So there are these all considerations what they have interdependency. So the dependency of Bluetooth low energy devices will always be where the expectation is there is a smart gateway. The smart gateway could be your phone, or could be any device in your home which is connected to internet, and not all the things in your home by itself. So this really saved in terms of to make things low cost and low power, all possible with this. Okay, now concepts in Bluetooth, where if you are an application programmer, you will more frequently or often come across this scenario, which is called profiles and services. Profiles are nothing but their definition of what are the possible application, or the major use cases, and one profile can have multiple services. And what is a profile? One example is the heart rate is a profile, or the proximity. Yesterday, if you had seen a demo given by Nitin, he talked about a device, a phone and another microchip. He just extend the distance, and you could hear the beeps. The reason was the proximity profile was the one that was implemented in one of the device. And services are the human readable specification, which means that a battery service or the various services that are offered are going to be part of profile. So if you choose a profile, you get a set of services, and also the consideration, also the components along with that. So normally when you're doing programming, these services will translate to a class, and whatever interfaces are nothing but what are the behaviors that you expect from each of it. In a programming term, that's what it is. And one of the key things you have to consider when you are programming is profiles that are not supported Bluetooth low energy are the handset profile, the OBEX, nothing but the object exchange profile, and audio profile, as well as the video. So these are the ones which are more connection oriented. That is where you will not find them in low energy protocol. Okay, so I am done with the main topics I had to cover. If you have any questions, yesterday I could see that there were some questions coming and we didn't have time. If you have any questions, I can take it now. Yeah.
So you talked about the classic versus 4.0.
Correct, yes.
Then you talked about in between there's going to be a dual mode.
Correct, yes.
Essentially would be something which the mobile handset manufacturers have got to do, right?
Correct, yes.
So would that be a radio upgrade, hardware upgrade, or it is going to be more of the firmware upgrade?
It is a hardware upgrade.
Okay, so
because right from the radio frequency you are doing it, right?
so does essentially it means that 4.0 uses the different frequency band?
Yeah, no, not the frequency band. It is still in the same ISM 2.4 band, but the thing is, in terms of the packets that needs to be sent, finally it is going like you are logically simulating a wire in a wireless environment, right? Whatever is translated in the radio frequency level, it's a different one. So it will need a different chip altogether.
Okay,
it's an hardware enhancement.
And I'm just giving a very hypothetical situation.
Sure.
So assume that your device, most of the smartphones today, except few high-end models, are classic, Bluetooth classic, correct?
But if you see iPhone 4S and above,
which I'm saying that very few.
Yes,
let's look at it. That maybe that's there, but there are very few.
Okay.
Would there be a possibility that, like what you see in the Bluetooth mouse and the keyboards, that you can insert a dongle and then you can communicate? Would that be a possibility even with the smartphones, that I don't have it, but can I include a module and still operate?
Okay, I have not come across any products like that yet. where it's like, you know,
be possible from a technical standpoint?
Technically it should be possible, yeah, because you are just translating. What you are doing is you may have an interface like the micro USB what you connect. It could have an additional interface where, you know, it is having that radio frequency whatever required for 4.0. That should be possible. Technically it is possible, yeah.
Okay.
Hi. Pro and BLE are one and the same.
Yeah.
So can you just give us details on how different both of them are?
Okay, so specification part of it, they have retained in terms of the compatibility or the compliance with the radio standards, whatever was mentioned in Classic, they are carry forwarded. Okay, so the 4.0 specification is a superset of whatever they have done so far. In addition, the primary part they have added is the Bluetooth Low Energy. So what they are mentioning is, earlier you could do it with a non-low energy type models. You were doing it, that is part of the 4.0 specification still, and any enhancements or the compatibility issues they had to sort out, they had still maintained that. Okay, the new versions of 4.0, that's what they. But if you come to low energy, that's a complete new section they have added to say that, you know, if you want to be compatible, these are the specifications you need to follow. But they are not synonymous or equal. It's rather the 4.0 is a superset of what LE is actually.
I have two questions for you. So
Sure.
first you talked about the profile, so that's
Correct.
orbit and proximity.
Correct.
So is there any data profile, you don't have any kind of data profile where I could send actual data?
For LE?
Yeah, BLE, specifically to BLE.
BLE actually you can overcome lot. The heart rate profile is nothing but a data profile only.
Oh, heart rate is a data.
Yeah, heart rate is a data profile because finally it's translating to some attributes. Right. Okay. Earlier, what they were doing is they were entirely defining. If you have in a programming paradigm, you have to explain, right? They were defining the classes and the interfaces and giving you. Now, attribute and value is what is the most basic element. On top of it, you can build whatever you want. Okay. So if you are a person who is a hardware manufacturer, heart rate or something, you can just say that I am going to send heart rates at this frequency, and then you are going to receive frequency in the periodicity. That one.
So second question is, do you think this will replace something like the 802.15.4 specifications? I mean, how different is this? Like,
if you see, Bluetooth, SIG and IEEE have a close collaboration. So though in the initial days, 802.15.1 was with which they have derived, right? The 4 is nothing but the low power part of it. So this is in close collaboration with them only.
So the 15.4 can run a complete IPv6 stack.
Correct.
They have a link layer and the IP layer. So you see the movement forwards in this BLE also having those stack?
In BLE, at least one of the current limitations of streaming or the voice capability which is not there, there is a thought that in 4.1 they are going to introduce. So as and when they are going to grow, they may be introducing that also. Yeah.
Okay, we're retaining the low power.
Yes. Okay. Yeah.
I have a question. This is about the connectivity.
Yeah. Okay.
Connectivity in terms of like what are the different modes by which pairing and without pairing broadcast. Can you throw some light on that? To the smart.
Okay. That's a good point, because if you see the things may not have even a display, or they may not even have a entry for entering a key or number, right? So they are going to retain the options which they had in Classic. Okay, there is no separate new method. If you see, there is one option called keyless. There is another one where the display of something happens. A 6-digit number happens on the other. You just need to confirm if it is the same device. It just validates that are you seeing the 6 digits on the other number. So they are going to maintain those mechanisms for the low energy part also. So the pairing experience is going to be the ones on the lower sides, but they are going to add the security when they are going to negotiate with the device. So typically the pairing is the first time you initiate discovery and then also pair with the device. After that, they are going to have something called a temporary key between the host as well as the device, so that the transmissions or the communication is secure after that. So they are going to retain the classic parts only, which are like some are keyless, which are just pairing without any security. They are going to retain the same.
Any other question we have?
Yeah.
Again, so I just
Sure.
want to clarify more.
Huh?
So do you have these concepts like MTU on this like broadcast and broadcast communication?
LE has that restriction. If you see the PDU, I think it's around 27 octets or 29 octets. So it's trying to put a cap on that. Yes. Okay. If you see the other classic, they really did not have. They can go to 1,000 octets kind of. Yeah. So there is no limit. But in this one they are having, because the amount of time spent in one-time communication, they wanted to reduce it drastically. So that is one of the.
I see actually a lot of limitations in terms of sensors and